Assalamu alaikum everyone. Welcome to the Eduverse, a universe of learning. I hope you all are doing so well with your family, with the happiness and joy. Assalamu alaikum. Today we are going to talk about very key and important concepts of physics, that is, we will have measurements, errors and the significant figures. Understanding the importance of the precision and limitation in a physical measurements. So this will be the today's topic we are going to discuss about, and this is obviously presented by the Eduverse. What are the measurement errors? Uh, if you look about this word, error means some problems, we can say. Measurement errors refer to the unavoidable difference between the measured value, this point measured value, and the true value of the quantity. So it's actually the difference between these both. These errors are present in every scientific measurement due to the limitation in the instrument, and these measurement errors comes either due to the limitation of the instrument, or faultiness in the instrument, or the human judgment, or the human limitations. The measurement errors come in the measurements. Recognizing and analyzing these errors helps in improving accuracy and understanding the reliability of results. Uh, figuring about the errors, like from where either the from error in is instrumental or the human error. Recognizing that figure of factors, and then analyzing that, and that will help us to improve the accuracy and to improve the measurement, that will improve the accuracy and reliability of the results. So that's actually the measurement errors actually. We have three main types of measurement errors. Measurement errors can be characterized into three main types. Like we have three different types of measurement errors. The first one is systematic error. The systematic error are consistent and repeatable, often due to the faulty equipment or incorrect methods. Like sometimes we have the instrument with the faulty measurement, like the scale on that is not accurate, or having some roughness fraction in that instrument using we are using in the measurement. So the errors coming up because of the instrument, we will say that it's the systematic error, because that's totally because of the faulty equipment or the incorrect methods of the using the instrument. The another one we have is the random error. The random error is actually, if we look about this word random, means that any um, like it will come from anywhere. We can say that occurs unpredictably due to the changing experimental conditions, like the change in the unpredictable in the condition of the experiment, mean changing in the temperature of the surrounding of the experimental area, or humidity, or all this the temperature, pressure. These are actually the random errors, because it's totally random. We don't know when will be the temperature will go down, and when will be the temperature go up. So all these is unpredictable, and we don't know about it, don't knew about it. So these are actually the unpredictable errors. We can call it random error. The third one we have is a gross error. Gross is errors results from the human mistakes, like reading instrument incorrectly or recording wrong data. Like it's this one type is totally about the human limitations. Like if a human do any mistake in the in experimenting some experiments, so that are taking, yes, here we have the recording the wrong data, or using the instrument not in a good way. So that will, yes, give us the measurement errors, and that type of measurement errors we can call it gross errors. Now we have little bit description, little bit detail about the systematic errors, like and also helps of the improving, like how we will improve these errors, like to how to make it reduce. Systematic errors arise from the consistent flaws in the measurement system, such as the miscalibrated instrument or the zero error. As I have told you before in the previous slide, that the systematic error totally comes from the instrumental limitations, and the limitations can be in the form of unvalid measuring scale, or like it's a fully fractioned instrument, like that fraction will cause the measurement errors, and also the zero error, the least count error of the instrument. These errors affect all the reading in the same way and can often be identified and corrected through proper calibration and improved techniques. So these errors can affect all the readings. The total reading will be affected, can be affected by this systematic error, and it can be and like how we can improve, or how can we can reduce this error. We will find about, or first we will identify it, means that figure out what the problem actually and correct it through the proper calibration, and then we will correct the calibration of the, means that is there any problem in the instrument error. We will find about it and correct that calibration and improve techniques. Also we will use the instrument for the multiple times to improve the techniques, so that will become reducing about the systematic errors. Here we have the second one, the random error. The random errors are unpredictable variation that affect the measurements differently each time. Like we do for the first time experiment, the temperature is 65 Celsius for example we are taking it. After some time we are doing the experiment, the same experiment, but the temperature is 45 Celsius. Again we do the same experiment, but the temperature is actually 25 centigrade. So all these are the same experiment, but due to the random error means due to the temperature difference, it will give us different values, and that error is actually come from the random error, from the unpredictable surrounding of the experimental area. They may result from the environmental changes or limitation in the human reaction. As I told you that the environmental changes are the limitation of the human reaction. All these will affect the actual measurement and will come with the random errors. So how we will improve, or how we will reduce, is taking multiple measurements and calculating the averages is a reliable method to reduce their effect. So make it different times, like different times, multiple time, or calculating the average, like we have different measurements, we will take the average of all these, and that will help us to reduce this effect, if reduce their effect on the measurement, actual measurement. Now we will have another basic and important concept of the physics, that is accuracy and precision. Accuracy actually refers to how close a measured values is to the actual or the true values. Like we can say that how much the value is close to the actual value. Like we measure some values and we will check that how much these different values are close to the actual value. So this is actually the concept of accuracy. And what is the precision? Precision is different of this. First I will tell you in a very simple way, that we have multiple measurements. We will check that how much these measured values are close to each other. Like we have an accuracy, like the measured values, how much it is close to the actual value. But in the precision, how much the measured values are close to each other indicates how close multiple measurements are close to each other. Yes, here we have, and precision indicates how close multiple measurements are to each other. Means like here closeness with the actual value, and here closeness with each other. Here's the difference between them. A measurement can be precise without being accurate, and vice versa. Like yes, it's correct. Ideally, scientific measurement should be both accurate and precise. The scientific measurements we have, that should to be both accurate and precise as well. Maybe we will have some examples on it, that over there you will get the greater insights about that. So here we have the another one. What is the significant figure? Significant figures are the digits in the number that carry meaning regarding its precision. It's actually a number carrying meaning regarding its precision. According to its precision, it will carry some meaningful numbers. They include all certain digits plus one uncertain digit. This is actually the main point about the significant figure. The significant figure also actually include certain digit, like we have the actual correct or true value, and also with the some whatever what can I say, some uncertain, like we don't know about this, either it is the greater or it is less. So it's the sum of all these two type of digits, like the once again I'm telling you, they include all the certain digits, like the true values, we know about that, okay, plus one uncertain digit. Like this uncertain mean we don't know about it. Using appropriate significant figure ensure that we do not overstate the accuracy of the measurement. So using it, we will ensure that we will never use or we will never overstate the accuracy of the measurement. There are some rules for counting the significant figures, like how much significant figures we have in a measurement or in the readings. All non-zero digits are always significant. Any non-zero digits we have in the measurement will be significant. Zero between the significant digits are also significant. Yes, the zero between the significant figures will also be considered to be significant figure. Leading zeros before the first non-zero digit are not significant. Like we have the 0, 0, 0, 0 and 1, the first non-zero, and before that any zero we have, that will be non-significant. Trailing zeros are significant only if there is a decimal point. If we have a decimal point on the right hand side of that decimal point, the zeros will be significant. So these are some rules for the significant figures. You must learn about it, have some practices, and find about it. Rounding off in the significant figure. When rounding numbers to the correct number of the significant figures, we will use these three concepts we have. For example, if we have a number, if the digit after the last significant figure is more than 5, if we have a number whose last significant figure is more than 5, we will round it up, and we will mean that the whole number will be up and goes to the up one. For example, if we have 5, 3 and 4 and 6, so we have the last digit is greater than 5, like 6 is greater than 5, so we will round it up. The second the another number from that will be goes up. Like for example, if we have 5, 1, 3, 6, the last one is 6, so it will goes up, means the 3 before that will be 4, will become 4, because the 3 will be come up, because the last significant figure is greater than 5. If it's less than 5, leave it as it is. So if the figure, for example, that taking the same example as well, 5, 1, 3 and 3, so means that we have the last digit is actually less than 5, so leave it as it is. Don't move the 3 to the 2, but not, yes, leave it at the same. 3 will be left in the same. If it's exactly 5, round to the nearest even digit. If the question, if the last significant figure is exactly 5, then we will go to the nearest even digit. So these are the three rounding off rules for the significant figure. This method maintain accuracy and avoid biasness in the data. This will give us the accurate, will move us to the accuracy of the measurement, and will avoid us from the wrongness or the biasness, any conflict, and any wrong, any problem of the data. Importance of the significant figure. Using the significant figure ensure that the significant data is represented with the appropriate precision, as we have discussed before. It prevents misleading confusion. Yes, it will give, if the measurement is accurate, then we will don't have any misleading confusion, because because our measurement is totally accurate and reflects the reliability of the instrument used. And yes, if the accuracy is maintained, means that it will show the instrumental reliability. Clear communication of data. Precision is a hard mark of the good scientific practice. So if the data is totally precise, we'll give the accurate resolution or accurate reading of the measurement. So it's a summary about all the slides. All measurements have some level of the error, which can be systematic, random, gross, all that we have discussed. Accuracy and precision are the key to the reliable data. Yes. Significant figures show the precision of the measurement. Yes. Proper rounding and reporting practices help maintain the scientific clarity. So this is all about the today's topic, that is very important. And thank you so much for watching. If it is helped well, so please subscribe this channel. We will have a glorious journey about the physics and different some educational concepts. Thank you for watching. If yes, it's requested, if you want to suggest any improvements, advices, suggestions, it's pleasure for me to get all these. And my comment box is totally open for you all people. You can ask, you can suggest, you can everything say. And also my email is attached with the with my channel. You can also contact me personally. I will respond inshallah, and we will grow up and achieve all things. Thank you so much, and Allah Hafiz.